Welcome back to Analytical Engine number 17, where last week I showed the accumulator section doing some simple math. And the biggest thing to note was that in that math there were no carries. The accumulator doesn't have a connection for carries from one level up to the next. So when a figure wheel goes 8, 9, goes back to 0, nothing changes in the digit above it. So that's the next section of the machine I'll be working on. The general plan has 3 carry sections, one for each accumulator, but they can actually be connected to other parts of the machine in case you want to use that hardware for other operations. Last time we did 6, 4, 2 plus 1, 2, 3, and all the digits are added at the same time, but there were no carries. If instead we have 6, 4, 2 plus 1, 2, 8, then we're going to have a carry in the first digit. So like before, all the digits are added at the same time on those figure wheels without doing any of the carries. So this column, the figure wheel moved from 9 to a 0, but there was no carry back. The easiest way to handle the carries is sequentially, like you would when you're doing it by hand. The figure wheels are still added at the same time, and then you handle the carries separately. So you look here, there's 1 carry, change that one. Next, there's no carry, and there's no carry. This is actually what was used in the difference engine too, and it looks beautiful. You have these spirals going up the machine, one for each column of digits, where the carry propagation starts at the bottom and moves up 1 digit at a time. The problem is, it's very slow. You're doing 1 digit at a time when your add was doing all the digits at the same time. So as the machine gets taller, your percentage of time used doing the carry gets more and more. And very quickly, your carry is taking many times longer than the actual addition part. So Babbage spent a lot of time to figure out how to increase the speed of this carrying, and he came up with his anticipating carriage, which does all the digits at the same time with some extra hardware. And it doesn't matter how tall the machine gets in terms of number of digits, it always takes the same amount of time whether the machine is 10 or 50 digits tall. So the logic he came up with is, if a figure wheel went from a 9 to a 0, then you need to carry in the next digit up. If the figure wheel is sitting at 9 and the previous one had a carry, then you keep that carry going higher in the chain. So if we do another example where we're going to have carry propagation, first we add up all the digits normally, then we check the carries. This one was at a 9 and now is a 0, so there's a carry here. This digit is at 9, so if there was a carry here, we keep it going. And then we add in all the carries at the same time. We have the 8. Here this is 10, but we already handled the carry, so it's just 0. Here's an example where that carry chain is going to start, then stop, then start again. So first we add the digits all at the same time without the carry, and then we look at all the digits at the same time to figure out if there was a carry. So here it went 9 to 0, so there's a carry in the next one. Here it also went 9 to 0, so there's a carry in the next one. This is sitting at 9, so you copy that carry to the next row, and then add them all up again. To physically make these carry chains, the base piece of equipment is an arm with a hole in it and a peg that you can push up from underneath. So if I'm pushing from this level and something at this level is on the same plane, then it will also get pushed up. But if there's nothing here, then nothing happens and the chain is stopped. By the end of 1836, Babbage had all this figured out, and these woodcuts are the basis of the machinery that I'm going to make for this analytical engine. The design changed a few times to address some of the shortcomings of this, but the overall concept remained the same. Here's the top view of the anticipating carriage. This gear is the same stepper gears that we saw in the accumulator, and this is how everything is actually connected together. Next you have a pinion that you can align or not with the figure wheel on the carriage. So that allows you to do operations without using the carriage. And next, the figure wheel itself has two parts added onto it. First is these little tabs, which when they move across, they will push that warning arm out of the way. Next is these arms, which are the ones that carry the peg that can move up and down. You can see that if this piece moves straight up and down, that peg is in the gap, so it won't actually push anything. But if this is turned and then moves up and down, this piece will also move up and down along with it. And this is what eventually pushes your carry up to the next level. So when this goes up and down, so does that, and you get your carry. In the normal position, this arm does not make contact, so nothing happens. There's no carry in the next level. But as your figure wheel comes from 9 to 0, you can see that this gets pushed out, which pushes that one, which lets the carry go up to the next level. So that's the first part of the logic. When the 9 goes to a 0, carry in the next level. The next part of the logic, when the figure wheel is at 9, the arm with the peg is lined up with that spot. So if we go to the side view, you can see it's lined up here. So this does the carry propagation, where the carry from underneath pushes up this piece, which pushes up that, which moves your carry to the next level. Unfortunately, this doesn't show nearly all the parts. Here's a better idea of what it actually looked like. A few of these parts are shared with the accumulator, but most of them are not, so it's going to take a while to make all of them. Shouldn't take 4 months like the accumulator, but I still have a lot of work to go. Hopefully this will be a bit easier to understand when I actually have parts I can show you with. Maybe that will be starting next week. But until then, here's a link to another video that shows this anticipating carry a bit better. And I'll finish with some amazing drawings from 180 years ago.